So we talked about heating a house. Now that we calculated the heat loss, what are the options that we have to heat a house? If you have to design a house and you want to heat a house, a cabin, you bought a house, you want to go and see what are the options. Let's say you bought a house, you want to flip the house, or the house that needs some work. What are my options? How much is it going to cost me to heat this house? The system needs to be replaced, and what are the options? Most systems last for like around 20 to 30 years. If you bought a house at 50 years old, probably the system needs to be replaced. So what are options? And the technology has changed a lot. You can do a lot of ways to save money and make things a little bit better. So we're talking about heating options. To be frank, the industry is moving towards, the industry and the Department of Energy is moving towards what kind of heating?
Electric.
Huh? Electric. Heat pumps are the new thing. So the Department of Energy have a goal that by 2050, all heat sources is going to be electric. Because it's safer, it's more efficient, and we can control whatever combustion we have in a plant. So that was one of the arguments of having electrical cars is, yes, electric cars consume the energy and fossil fuel eventually at the plant. And we have a lot of losses in the wires, the cables. So there are some losses, and eventually you're using fossil fuel. However, when you have the fossil fuel in a plant, you can control what are you spacing into the environment, what gas are you producing, and you can make it more efficient. Meanwhile, you can have somebody with all cars, like 25% of cars with really bad combustion, bad catalytic converter, dispensing CO2 everywhere. That was the argument. Same thing with the heat. They can provide you with power in a safe manner. Instead of you having your boiler not being maintained for 3 years with combustion efficiency of 50% and paying gas at $3.50, $3.50, that's a lot of money. So you're better off going with a heat pump and let us worry about the combustion. And also a lot of people have the idea of having fire in your house. It's a little bit creepy. There's fire going on and off in your house the whole time. It's a little bit disturbing. That's why they don't have a glass or a way where you can see that there's fire inside. You just know there's gas. For the longest time, a lot of people thought, okay, it just makes heat out of gas. How? I don't know. Actually, it's burning gas inside. It's a complete combustion. We talk about combustion. Combustion is still going to be ongoing for a while. In Massachusetts here, we have at least 50% of houses have oil, 50 are gas. It will make sense not to convert to gas if you don't have a gas line, to go with a heat pump. It's a good replacement. And for combustion, 21 is air, 79 is nitrogen. We need to learn about combustion because it is going to be here for the next 10 or 20 years. And the next semester, I'm going to dedicate a whole class to oil burners because they're more involved and they have more components and they have more problems. And probably we'll be working with those at some point. Oil companies are looking all the time for technicians. If that's something you're interested in, you're good at, you'll be hired really quick to do oil. Either by Columbia or either by a utility company or a small company. The number of oil technicians is really dwindling. There's a lot of job opportunities. Why do we need the right mixture of air and fuel? We thought about the whole combustion. If you have too much air, you will have smoke. You have too little air, you have smoke. What's the problem with smoke? Besides that, you're not burning the fuel efficiently.
Cost soot.
Soot. What's the problem having soot? Huh? It builds up. If it builds up,
Losing efficiency.
what is the part of your boiler that absorbing the heat into the system?
Heat exchanger.
Heat exchanger. If the heat exchanger has a thick layer of soot in it, it's not absorbing the heat. If you burn gas at 600 degrees, and it's coming out 600 degrees from the vent, what does that mean? Nothing is going to the system. So you're losing all the heat and you're not absorbing the heat and you're paying for this gas. So we want to have the right mixture, not too much and too little. Primary and secondary air, that's something we have to think about as well. Primary air is what you introduce with your fuel. Secondary air is a gate that apply extra air once you start the combustion. Example in the car. In your fuel injection system, or your carburetor, it will pump fuel into your engine. Usually it's a mention. It will pump fuel and air. But there's also some secondary air to the door and a damper that will allow the system to get some more air in. Especially with the carburetors, because they are less metalated than fuel injection system. So the same way here, there's always a damper, and there's always a vent on top of the system to allow more air to come in. We look at this scale looking equation. You don't have to know that, but just to explain to you what's happening and what is combustion in chemistry. This here is petrochemical, hydrocarbon. What is hydrocarbon composed of?
Hydrogen carbon?
Yeah.
Oh.
This question always actually happens in always comes up in the oil burn exam. Yeah.
You say we have to know that?
You don't have to know that. You don't have to memorize the whole thing. Please understand what it means. You know what's an equation? It's a balance between two things, and this is what we're balancing trying to do. So, hydrocarbon, any material that consists of hydrogen and carbon. Most petroleum products are hydrocarbon. And if you're going to take the oil burning exam, they always ask you a silly question. What is hydrocarbon made of? What are all fuel oil made of? Hydrogen and carbon. Don't forget that. The X and Y, what does that mean? It could be any number. So I'm just going for an example. If it's X is 2 and Y is 7, that's probably gasoline. If you change the X is 4 and this is 12, probably that's
Also,
not
X and Y.
it's just a number.
Can represent
Could be
any
any number. Any number. So, but any hydrocarbon is represented by a chain of carbon and hydrogen. O2 is oxygen as it exists in its natural state in the atmosphere. Nitrogen, 79% of the air is nitrogen. It's there, we do not use it, we do not want it, you don't even want it in your body. Your body does not absorb nitrogen unless it's what? Huh? No, that's not that's different. When does your body absorb nitrogen? At least he's thinking. That's a good guess. Yeah.
It helps you carry oxygen around by dilating your blood vessels, right?
No, but I'm not sure about that. But my question is, when does your body absorb nitrogen?
When you breathe.
No.
When you die.
They said that. It's so morbid today. No. No. It's when your body is under pressure. So if anybody works in the marine, and you have a lot of people who do scuba diving, when your body is pressurized, it will absorb some nitrogen. And getting rid of the nitrogen that's been absorbed in your body is an issue. It takes a long time and can cause something called the bends, where you have bubbles of nitrogen in your body. So your body does not absorb nitrogen. The spark is has to be the right temperature to ignite the oil. We have the fire now. It is going. What are we getting out of it? We're putting in this component. We put a spark. What does spark happen in your burner? There's an igniter, right? It's always an igniter, ignition. In your car, you have spark plugs. This is coming with air. This is the plug. What are we getting? Fire. Fire has heat, CO2, carbon dioxide, water. Fire always has water. That's a byproduct. It's always vapor coming in with the fire. X is nitrogen, didn't burn, it's gonna come out. SOX, SOx, which again, what is X? Could be anything. Yeah, sulfur
Oh,
oxide.
that's what it means. Oh.
Yeah, X is any number. Sulfur oxide with any number on any chain, or nitrogen oxide. Those two byproducts are not desirable, and that's why we said again, we would rather have combustion in a power plant where you can control all these byproducts. Question? Or, hold on. What?
Can you have the first part of that reaction happen without the nitrogen? And then it'll
Yeah.
just do the second
Here?
part without the nitrogen? Yeah.
Yes, you can. In a controlled environment, if you have an oxygen tank, yes, you can. We have to you're gonna have different equation.
No, just because spark equals heat, isn't H2O water?
Yeah.
So you shouldn't throw water on fire?
No,
Depends what kind.
that's understandable. Water does not come as liquid, it's gonna be vapor.
It's a molecule.
Yeah. or vapor. If you hold a glass to a fire, you'll see some condensation, cold glass. If you have one of those fireplaces where the glass is so cold, you'll have some condensation. So water is gonna be a byproduct of the fire. Any other question? We're gonna do a lot of combustion. We're gonna think about combustion a lot, we're gonna go in details, and hopefully you'll be very fluent into working with combustion. We will do both gas and oil. But this is the basis. Always think about that. If the spark is not efficient, you're not gonna start ignition. It has to be at the right temperature. We're beginning heat, carbon dioxide, water, nitrogen. We talked about this in week 1. We said BTU. Yeah, I'm just repeating it. BTU is a thermal unit for measuring heat. In HVAC, usually it's BTU. You'll see everything in BTU. You'll see some equipment that comes with kilowatt. Mostly European equipment, they'll have kilowatt. Some companies now, they provide you both, BTU and kilowatt. The conversion between BTU and kilowatt is, 1 kilowatt is 3,400 BTU hour, if you want to convert the piezo. So 1 watt is 3.4 BTU. Calorie, another unit, and horsepower is another unit for commercial boilers. So if your body, I did this math again in the beginning, but I'll repeat it again. If your body would be a light bulb, it will be a 100-watt light bulb. This is how much heat you generate. So 100-watt light bulb on 24/7. It fluctuates, but on average 100 watts. Burners. So again, at least I think every house I've seen so far in Western Mass have a burner. There's always in the bottom floor, in the basement, you'll see a burner. It could be gas, it could be oil. I haven't seen more than those two for residential. And you're gonna have some water going through it or air. If it's air, it's a furnace. If it's water, it's a boiler. And this is basically what's happening inside. Primary air is coming with the fuel. If you look at the gas, what's it called? Manifold. Look at the gas manifold. It's the gas is not coming completely. The gas is shooting through it and has some opening, so the air will come with it. And this is calculated, so you'll have both shooting gas and air as primary air. You'll have an opening at the top to allow secondary air to happen. Why do you need secondary air? When you have the fire combustion. So the primary air is required to start the equation, to start the combustion. If there is no air, there is no combustion. Once you burn it, it will consume more air, you have more combustion. And that's why you always, when you turn the gas stove, you hear a poof. It always poofs like that. Yeah.
So would air from a inducer fan, that's pulling the hot air from the fire, would that be considered secondary air?
No, that's primary. That's
Even
primary.
though it's taking place after combustion?
It goes with it.
Okay.
It goes with it. For oil, there's an inducer fan that's pumping air with the fuel. For gas, the fuel is shooting. As it's shooting, it's very fast. It's causing negative pressure, so it sucks in air with it. We'll talk about that in more detail.
Same as the fuel injector in the car.
Yeah. Yeah, it does have air with it. Complete mixture already. This is the combustion chamber, and as the air comes up, there's also some negative pressure, so you have to always supply dilution air or backdraft air, so you don't have some air coming back to your chamber, coming out. So this is basically what we do in all burners. Fire inside, and what do you have here?
Chamber wall.
Yeah, what else? Fluid. Huh?
Your fluid.
Yeah. What else? Heat exchanger. You're gonna have a serpent like looking like a pipe that the air will go through and it should absorb the heat. And that's not condensing boiler. What's a condensing boiler?
Boiler that condense.
How? So, bear with me for a second, because now probably you wanna go stop by a warehouse and look at what they have. So if you go now, everybody's going to show you a flyer about nice condensing boiler. So remember what Dave said about water? If we absorb all the heat from the fire, what's gonna happen to the water? That will condense, become into droplets, and you'll have some water dripping out of it. So if we burn fuel here at 600 degrees, and we want to get all this 600 degrees, or at least 500 of it, the air coming out is going to be around 60 or 70 degrees Fahrenheit, which means all the vapor inside the combustion, out of the combustion, is condensing. What does water has with it? Sulfur, SOx and NOx, and other byproducts. So that's what they call them, SOx and NOx. You're gonna hear that a lot. Slow SOx state, low NOx state, that will, so bear with me for a second. Condensing boiler will have different configuration, however, the water condenses, you get a drain of water, but it has to be run through a filter. But you get what we want, which is all the heat coming from the combustion. So the vapor will condense, it will drain, it has to go through a filter to neutralize those toxic material that you don't want to dispense into your sewer. So that's a conventional non-condensing boiler. Now there's a lot of condensing boilers. Condensing boilers require more piping. It's not that difficult. But,
Oh,
huh?
sorry.
Yeah. They require more piping and more, and it needs to have a drain and a filter that you change once a year. But if you think of the benefits of low consumption, low fuel consumption, it's completely worth it. And fuel installation, they always advise you to have a condensing boiler.
Isn't the vent on condensing boilers PVC because it's not as hot because
Yeah.
the gases aren't as hot?
Yeah. So the vent and pipe are all on PVC, does not melt, does not react.
Hopefully.
So we talked about the seal design. We said that seal design are very recommended because all the air coming to the boiler is from the outside and from the basement, and all the discharge air and vent air goes to the outside, not to your chimney, not to your main vent. So this is what it looks like. You have one hole in the wall, it has the intake and the outtake, and if you look at those designs, usually they are very small, and they look like a small little closet that you can hang. And most on-demand gas furnaces, they use this technology. Gas furnaces, again, remember the range. There's also conversion kits for oil burners to use gas. You can go and size the gas range that you need for the manifold, give you the right flame. Yeah.
So if you're converting an oil burner to a gas burner, would you still have to do as much maintenance on it since it was originally an oil burner, or since it's burning gas now, you don't have to do as much?
It's not going to be as much because you don't have to change the nozzle as much. The soot is less than the diesel. Fuel oil always gives a lot of soot, a little bit, especially in the beginning. So gas requires less maintenance, but you still have to go once a year and check the solenoid and check all the components. They recommend once a year to go and check the components
For gas?
and also check for gas leaks.
Damn.
So that's what Karen was talking about. You can use plastic and PVC because it's not that hot. It's around 60 degrees, which is very normal. So it doesn't get that hot, so the PVC is not going to melt and it will dispense the heat to the outside. That's a sealed option. That's so that's our heat source. You're gonna use either gas, fuel oil, or wood if you want to. But I don't think it comes as a burner, or you can use a heat pump. You can use a heat pump that connect to the same manifold. You can use a heat pump to do hot water system. You can use a heat pump to use hot air system. So to move the heat from the basement to the house, you need to use some kind of fluid. So either hot water system, which is hydronic, or forced hot air. So hot air system, that's what we have over here. It's hot air. It's fast because it's heating or cooling the air, and we interact with air, so it's very quick to feel the heat or the cold. It can be coupled with air conditioning, so you can have the same air handling unit connected to a condenser or evaporator, actually an evaporator, and also a furnace. And we see this in the shop all the time. Guys, phones off, please. More losses. That depends on how far are you pumping your air to your room.
Wouldn't that be a disadvantage though, not really an advantage?
Huh?
Wouldn't that be considered a
What,
disadvantage?
it can come over AC?
No, more losses.
Well, that's a disadvantage.
Or you're losing more of the hot air though.
That's actually should not be a disadvantage. That's a disadvantage. It's a mistake.
Alright.
Okay. So that's good. That's more losses, but it depends. Is it a disadvantage or advantage? Why? Because you might want sometimes to leak you want the duct to leak some heat.
So it's
to the
neutral
space.
then?
Yeah, that's why I said it depends. So the losses along the way could be used to heat your system, or sometimes you don't want it to heat that area. So if it's in your basement, you want to keep your basement on 60 or something. So that losses is accounted for. It's very versatile. What is meant by that? You can use it to clean the air. It has filters. You can put a UV filter in it. You can put a humidifier, lead humidifier. So it has more, because you're controlling the air coming to your house. So a lot of people like that because, again, you can filter the air. Again, if you filter the air, you have to change the filter once in a while. A lot of people don't do that. So if you go to any house that has forced hot air, if you look at the filter, it probably has not been changed for a long time. Especially if you have pets, you need to change the filter more often. No radiators, that's something a lot of people don't like. Some places where you have very small limited space, you don't want a big radiator sitting there taking space. Especially in kitchens, bathrooms, hallways, the radiator sometimes can be very big, that can take a lot of space. Disadvantages, requires humidity control, because again, you drying the air, you feel it more, so you need to put a humidifier. Forced convection is not very pleasant to people. Why? Because why? Draft is not comfortable. Nobody wants air blowing in their faces. So that's not really something people like. Yeah. Draft is not good. It circulates more air. Okay, don't we want that? Yes, but yes and no. If you have a lot of dust and pollens, and you don't want that to be stirred up in space. And also sometimes the return and the supply are for the entire house. So you are changing air with other rooms. For forced hot air is not really made for hospitals. Or for example, in a house when you have the intake near the kitchen, if somebody's making coffee, the entire house will smell coffee. So the intake and return is very important depending on the configuration. It's very costly. What is the costly part about that? The duct work is very costly. The maintenance is costly, but in the beginning it's very costly because duct is very expensive. Something has to be manufactured in a shop and delivered and installed. So that is the costly part, especially if you want to have good quality duct, not a flexible duct. That's what duct has. It's very cheap, but it also has a lot of losses. Any questions about hot air system? Does anybody have a hot air system in their house?
I had one in an apartment.
Yeah. I did not like the noise.
Loud as hell.
It's very noisy. That's another thing. People don't like the noise. That's the first job. You'll hear the fan, and air is very noisy. So a lot of people like the hydronic system. With steam you'll hear it at the beginning, but then it stabilizes. And water, you can hardly ever hear it or notice that it's there. Question?
So, do people dislike the ducted AC as much when it comes to like the sound and stuff, or do you deal with it because it's cooling you down?
That's a good question. So with the ducted AC, usually the sound is there, still there, but the amount of air you're pumping through the duct is not as much as hot air.
The joy of becoming cool makes you deal with it better?
say that, but again, what I try to say is the amount of air you're pumping through the
It's not as much.
the duct is not as much, which means there's less noise. And there are some inside big buildings, they have chillers, which is same as hydronic. You don't have air. You put the pipes in the ceiling, and the cold it will be cold, and the cold will drop. Cold will drop to the bottom and circulate. But forced cold air is not good for you. Cold drops is not good for you. That's how you get cold. You get sick, you get flu, so you don't want that as well. And again, that brings me to a good question. Let's say somebody had a an AC. The duct was sized for AC. And suddenly, they want to put a furnace in there. Oh yeah, I have duct. And you have to double check the duct is sized for both. Because as I said before, hot air require more CFM. So you're gonna have to pump more CFM through small duct, which makes it faster, right? It's going to be faster because I reduce the area, which does what? It will be noisier. It will be noisier and you'll hear it more and it will be very uncomfortable. Duct system also require insulation, and I said that depends. There are some losses. Sometimes you want to have the duct exposed because you want to account for duct losses to heat that place. Especially if it's a basement or an attic that you want to be not very cold. So you can lose some heat, but you have to account for it if you don't want to insulate the duct. Insulation can also be problematic because it wears off. And again, for insulation, please note that it is rated based on heat. So some insulation cannot take too much heat. It's meant to be cool insulation. Same with steam and water. So these are most of the common radiators. It's one of the radiators that actually work with water. It has bigger space. This is the baseboard radiator you see here. And the water flows through it, loses some heat. The heat goes to the wall of the radiator and they disperse. The more surface area you have, the more heat you will disperse and faster. These ones are very economical, very cheap, and in a way, it's like it is less invasive in the space. You go around the room. I find it still invasive, but depending where you put it. Advantages: it's very quiet. It might have some crackling noise at the beginning, for the expansion of the metals until it settles. With steam, probably you'll have some hissing in the beginning, the air vents, but once it stabilizes, you don't hear it anymore. More efficient in terms of the heat delivered. A lot of heat being absorbed by water than air. It uses natural convection, which means we do not need to force the air to move. And it can be a standalone system. It's its own system, has nothing to do with the AC. And in places where you don't have a lot of hot days, you might not need an AC. Just deal with heating by itself. Does anybody here that doesn't have AC? If you live in some areas and regions are colder than others, so you do not need to use this expression.
So since radiators are so heavy, would the spot where they're be in the house have to be more structurally, I won't say appealing, but have more support for the radiators so that it doesn't fall through the floor?
I think the floor standards should be able to take the the floor should be able to handle the weight, and it's not as heavy as one might think. It's as heavy as a person maybe. Like some of them are like over 200 pounds, so if the floor cannot handle a person, should not be handled. The point is you do not design for the radiator. The floor is designed
So
for
you don't have to add like a extra
No.
stud under or
Just
something?
put it in a bearing place.
No, it's not that. It's not heavy to the point where you have to specifically design for it. The floor designed for unit construction, right? What is the load on the floor per square foot? How much weight can it take?
It's 1,000 pounds.
Yeah. So from what I remember, it was I think it was per square foot you can put at least 100 pounds. So it's the floor is supposed to be handled that way. So good question, because they're very heavy. No, you don't have to add more structure, unless it's very old design and it's, the wood is saggy, maybe we have to think about that with some support. Because they are very heavy, some of them they go up to like 200 or 300 pounds. Anybody down the slide? This is some of the layout for this system. So we have our boiler, we have a supply line and a return line, and this is actually a good configuration because the supply goes to all boilers at the same time, all radiators at the same time, and the supply is separate. Another layout. We'll talk about these layouts in a lot of details next semester, but this is what they look like. One of the worst way to connect radiators is to connect them in series, one after another. Remember the same thing with electricity. You do not want to connect loads in series because what? The first one will get all the heat, all the pressure, and the second one will get less, and the last one will get nothing. So unless you have a studio or one room, do not do that.
They have electric meters.
Yeah, but those are very expensive. They run you a lot of money. So they have the same radiators which have a heating coil inside. You just plug it in. And it will cost you a lot of money. Steam. Steam is also hydronic. Advantage is very similar to water. You get faster heat until you boil the water. I mean, once you get the water boiled, it's very fast to heat the place. You get a lot of heat. The boiling water of the boiling temperature of water is 212. So you're gonna pump a lot of heat. After reaching 12, you start getting steam. When the steam is generated, you're good to go. Steam will fill the mattress, it will condense and keep giving you heat. So it's very quick, easy to control and zone because each steam mattress has its own valve. You can open and close it. And in some systems, you can put a thermostatic valve on each mattress, so you can control each zone temperature alone. Disadvantages, leaks, rust is an issue, depending on the system. Again, all these advantages and disadvantages, you can think about it as an individual system and how it's made. So leaks, rust, the pressure. So the pressure has something to, that's something we have to design carefully for. The pipes usually are very thick because it's supposed to handle the pressure in case we have a malfunction in the steam. Residential steam pressure is around 0.5 to 2 psi, so you don't want to exceed a lot of pressure. Again, building pressure is very dangerous. That's when you start like having explosion in a boiler. One of the disadvantages also is a large mattress radiator. They're very big, and that could be an issue. And they're very hot. So if you touch this radiator, probably it's not going to be hot enough to burn you. However, a steam radiator is very hot. It becomes cold. If you lean on it by mistake, it's really hot. Temperature is around 212, so it's very uncomfortable. That's why people put the mattress, then they put some kind of shield around it or a closet with vent in it, so with this breaks out the heat.
Started taking them out of houses because of kids, right?
Yeah, yeah. If you have kids, you don't want to have steam without closets. You have to build something around it. This is some of the piping configuration for steam. If you're going to be a pipe fitter or you're gonna work with steam, probably need a certificate to pipe steam, because if it's not piped correctly, you're gonna have issues. What did you notice that we had issues within this building?
Water hammering.
Water hammering. Probably something did not pitch the right way. Water hammer takes place when the water needs a lot of steam, and it traps the steam. Steam moves fast, the water moves slow. If they meet in the same direction, it will have a pocket. This pocket will cause some pressure, and eventually it will have some kind of hammer and explosion. A water hammer is not okay. A lot of people tell you it's okay. It's normal, it's not normal. It's actually the same force as a hammer banging on the pipe. Something will break. Your pipe will break, the wall, or some piece of equipment.
Would you say it's like a mini explosion inside the pipe?
Yeah, yeah. And don't let anybody tell you that vibration is okay or water hammer is okay. Long term, these things does go in your equipment, in your system. So this is the one loop system. The one loop system have the same, one pipe system, have one pipe coming to each radiator. So, can you imagine what's happening here? First of all, the mattress has air in it. The system is off. We're heating some steam. Steam comes up this pipe, goes up this pipe, start to fill the mattress. The air vent will let go of all the air. The steam will take over the mattress. It will touch the walls, condenses on the walls, and become water. When it becomes water, it will run from the same pipe where the steam is coming. So the same pipe here,
So with the steam and the water, they wouldn't be flowing at the same time?
yeah, they will be at the same time.
Then what about the water here then?
Well, that's why it has to be designed correctly, so you do not have, the amount of water running through that pipe should be calculated that it will not exceed certain level. So if this is the mattress here, and this is the mattress. So this is my valve. I'm not to exaggerate the valve. So steam is coming in the top, and water is running here. If you have too much water, the water has to be very carefully measured. If you work in any steam system, they tell you how much water it is. If you exceed that water with a little bit, it will start harming. So you have to be. So the amount of water coming in the radiators is carefully calculated. That's why you need somebody with some expertise to install this system. So in here, in this part we have steam. In this part we have water. The water will condense and goes back into the return line, and this line will be filled completely with water, and the steam will go to the top. So this, if you notice, if you look carefully, that's a 10-degree pitch. Has to be pitched a little bit, and too much. If you have too much, the water will go too fast and will cause the water hand. Somebody did not want to deal with all this nonsense, so they made a two-pipe system. What is the problem with the two-pipe system?
Places to go.
Too many pipes, a lot of connections, and eventually the house will be full of pipes and wires. That's not something desirable, and it will cost you more. The piping is very expensive, but the two-pipe system kind of solves this problem, and you have a dedicated line for water and dedicated line for steam. This is a wood stove. Wood stove can be a standalone system and can be vented by itself into the outside and sometimes through the side. However, you have to check the codes for the clearances of the wood stove. How much from the wall, 36 unit combustible from the bottom, and they're very, very simple to install. You can do that yourself. And some of the wood stoves, for the wood pellets, they have an inducer fan in it, and they also have a feeder. You open the top, and you pour all your pellets, and it should go through combustible completely. That's what I have for types of feeding system. And they have some, these types came from the book. There's some, next class we'll do clothing. For the Red Sox fan, was going to Boston on Wednesday.